Welcome to Brain Vision.
Hi everyone, so what we have is air in an insulated rigid tank whose volume is 0.5 cubic meters. We have an initial pressure of 4,000 kPa and an initial temperature of 20 degrees C. Air is released to reduce the pressure such that the final pressure is 2,000 kPa. What we're asked to find is the final temperature. So what we're going to do first is, as always, go and find the properties of our gas. So we have air. So we know that the gas constant R is equal to 0.287 kilojoules per kilogram Kelvin. We know that the specific heat at room temperature, our Cp, is going to be equal to 1.005 kilojoules per kilogram Kelvin. And we're also going to have our Cv, which is going to be equal to 0.718, same thing, kilograms per kilojoule Kelvin, or kilojoules per kilogram Kelvin. What we're going to do is actually take the tank as our system, since it is the control volume that is having mass cross its boundary. So we're going to do a mass balance. And when we do our mass balance, we know that m, the mass coming in, minus m, the mass leaving, is equal to the change in mass of the system. Now we don't have any mass coming in, so that's going to be 0. So all we have is mass exiting is equal to m2 minus m1, and that we can just write as me is equal to m1 minus m2. Next, we're going to do our energy balance. So we know that the energy coming in minus the energy leaving is equal to the change in energy of the system. And we have a rigid tank, so there's not going to be any work. However, we also know that the system is also insulated, so there's no heat transfer. So all we have is the energy leaving the system due to the mass flowing out. So we have negative me He is equal to m2 u2 minus m1 u1. We can actually just bring everything over to one side and say that 0 is equal to m2 u2 minus m1 u1 plus me He. Now what we can do is we can use the relation of u and h to the specific heats. So what we can rewrite this as 0 is equal to m2 CVT2 minus M1 CVT1 plus ME CPTE. Now we can actually combine the mass balance and this energy balance by plugging in that ME term. And what we get is that 0 is equal to M2 CVT2 minus M1 CVT1 plus M1 minus, and rewrite this, we get m1 minus m2 CPTE, and that is all equal to 0. So what we can do is go ahead and solve for our initial mass. So we can say that m1 is equal to pv1 over rt1. Actually, we have a rigid container, so the volume will be constant. We just have changing pressures and temperatures. So plugging in for these quantities, we get an initial mass of 23.78 kilograms. Now we can actually solve for M2 in terms of T2, since we don't know that final temperature. So we can say that M2 is equal to P2V over RT2. And we know P2, V, and R. We don't know T2. So we know that M2 is going to be equal to 34.84 over T2. So what we're going to assume is that the temperature of the air leaving the tank is the average of the initial and final temperatures. And this is because the temperature of the air leaving the tank changes from the initial temperature in the tank to the final temperature during this discharging process. So what this essentially means is that we are going to assume that the T exit is going to equal T1 plus T2 all over 2. So remember that our combination of energy and mass balance equation looks like 0 equals m2 CVT2 minus m1 CVT1 plus m1 minus m2 parentheses CPTE. So this TE term is this relation right here. So after we go ahead and plug in for all the quantities that we know, we'll see that 0 will equal 3484 over T2, CV T2 minus 2378 CV T1 plus 23.78 minus 3484 T2 CP times 293 plus T2 over 2. Now you'll see here that the only quantities that we don't know is actually T2, because CV and CP are values that we have gotten from the table and temperature 1 is given to us. So we have one equation with one unknown, and we can actually go ahead and solve for this. And we get that the exit temperature, T2, is going to be equal to 241 Kelvin, and that's equal to negative 32 degrees Celsius. I'm sorry, this is the temperature, the final temperature of the tank.